we have arrived back to the hidden chemistry village. On our way back, Kakashi Sensei wanted to help us follow changes in cell potential based on changing concentration. So let's go ahead and follow changes in potential during the zinc copper cell operation. First, we have our overall reaction as we see here, where our Q value is going to be determined mainly by the concentrations of our aqueous ions because we have a solid copper and a solid zinc. Next, we have a graph, a table, and another written table that highlight 3 key changes in cell potential as concentrations change. Now, because we are talking about concentration changing and the effects on cell potential, we are not talking about standard cell potential. We are talking about non-standard cell potential. So we definitely have to bring out the Nernst equation, which is going to be non-standard cell potential is equal to standard cell potential minus 0.0592 volts divided by N log of Q. And therefore, our Q value is directly related to our Q value that we can get from an overall reaction and plug in. And so we basically would take this entire Q value and relate it to our non-standard value, which again is also related to our standard value. So let's focus on the graph first. Again, all of this is going to help us understand that as a cell operates, its potential is going to decrease. So as you can see, we have the non-standard potential as the y-axis, and then we have our Q value as the x-axis. Okay, folks? And then we have everything in a straight line because we are dealing with logarithmic-based scales. So that means we can get everything in a straight line, which helps us as well. So let's start with stage 1. Initially, the cell does relatively more work because the concentration of Cu2 plus ions is going to be greater than the concentration of zinc 2 plus, meaning our reactants is going to be a higher concentration than our product. This is going to result in having a Q value that's less than 1. If our Q value is less than 1, then our overall value here, our 0.0592 divided by N, multiplied by our log of Q value, is going to be less than 0. If this value is going to be less than 0, and this is basically negative, a negative and a negative is going to give a positive here. So our non-standard E of the cell ends up being greater than our standard E of the cell because you're adding on that value. So our non-standard E of the cell in stage 1 will definitely be positive for the reaction. Okay, folks, let's go into phase 2. So again, we have Q is less than 1, Q is less than 1. Oh, wait, now we have a Q value that's equal to 1. What does this mean? This means that our concentrations of our reactants and our products are equal to one another. This also means that this entire value here is equal to 0, right? And so if this value is equal to 0, that means our non-standard E of the cell is equal to our standard E of the cell at stage 2. You also can say the cell is at equilibrium and can no longer do work. Now, of course, looking at the table version of this, it has everything I'm saying written out specifically as well. As the cell continues to operate and the concentration of products become larger than the concentration of the reactants, then guess what? Q is going to be greater than 1. When Q is greater than 1, then this entire value is going to be greater than 0. If this entire value is going to be greater than 0, then guess what? Now our non-standard E of the cell is going to be less than our standard E of the cell because you are now subtracting this value away. All right, folks? Another way of saying it is that the non-standard E of the cell is negative for the reaction as written, and therefore the reverse reaction will take place, and the cell will do work until QK is equal to 1 at equilibrium. Now, over time, folks, the amount of products are going to continue to increase. And so I can kind of like add a little tag over to here. It's going to continue to increase until we hit the value of 0 for our non-standard cell potential. Now, how does that happen? And we keep on increasing our products so high that this gets a larger Q value here, then that means this entire value is so large that guess what? It ends up equaling our standard cell potential. So if these two numbers are the same and we subtract them, then our non-standard cell potential is now going to equal 0. And so that's what ends up happening if we were to tag on a little bit the rest of our line all the way until it gets down to 0. Okay, folks? One application, which we'll get into as we go visit other villages, is that in all batteries, reactant concentrations are very far from the standard state. Okay, and so when it reaches equilibrium, that is when you actually have a quote-unquote dead battery. So you're starting at a high reactant amount, and then as you continue to decrease over time in the life of that battery, until it gets to 0, then the battery will not work anymore. Okay, folks? That is our wrap-up. Thank you, Kakashi Sensei. Kakashi then stops by the Hokage's office to get the rank or grade for our mission that we did at the Hidden Voltaic Cell Village. Okay? And the mission ranks are always based on difficulty, skill level, experience, and more. So for us, we ended up getting a ranking of B because yes, it was difficult to learn all the new information, but it was very low stakes or low danger since we already knew the villagers and we got so much help with all of from the Raikage himself, right? Let's meet Kakashi at the gates for details of our next mission. See you there. All right, the Hokage has given us our second mission, folks. Now, Kakashi states that this mission will involve a higher level of danger, but based on our training, he thinks we are ready. We must take what we learned thus far and help retrieve secret jutsu stolen from the 7 swordsmen of the Hidden Concentration Cell Village. So that means we were here now, and we're going straight to the Hidden Concentration Cell Village and the Land of Water. Now, these 7 swordsmen are rebel ninjas who want nothing more than to take over. And we have been given intel about their location and will be using it to our advantage. This means we must secretly learn what we can from any villager willing to help give us information and use it to battle them before they move to their next hideout. This also means this is an S rank mission, the highest level mission that can be given to a ninja. And Team 7 was the only crew left to help, so we must do the best we can, folks. We must make sure that we review and practice the voltage steel jutsu that we learned before as we travel. Let's go.